Welcome to today's presentation. Today we will cover continuous integration and build automation. As software developers, we are always looking for ways to improve our workflow and make our lives easier. That's where continuous integration and build automation come in. These practices allow us to streamline our development processes and to help us to deliver high quality software faster than ever before. Um, Continuous integration involves automatically building and testing code changes as they are made. This ensures that in any issues or conflicts that may arise can be caught early on before they become major problems. Build automation, in the other hand, automates the process of compiling and packaging code into a deployable format. This saves time and reduces the risk of errors. And by adopting both of these techniques, so continuous integration and build automation, we can save time, reduce the risk of bugs and conflicts, and ultimately deliver better software. So let's dive in and explore these practices in more detail. What is continuous integration? So continuous integration is basically a fundamental software development practice that brings numerous benefits to the development processes. By frequently integrating code changes into a shared repository, developers can detect conflicts and issues at an early stage, which in turn enables quick resolution. In addition to early issue detection, continuous integration involves the use of automated build and testing processes. This automation significantly streamlines the development workflow as a whole and allows for faster feedback loops and efficiency. By adopting continuous integration, we can, or I should rather say, by successfully implementing continuous integration, developers rely on the range of tools and technologies like popular CI tools like Jenkins, Drive CI, Circle CI, GitHub Actions even, to automate the build and testing processes, simplifying the detection of issues and ensuring seamless integration of code changes. With continuous integration, development teams can enhance collaboration, which is a major pillar of DevOps, like I told you in the first module, reduce integration problems, and deliver high-quality software at a faster pace. This practice forms the foundation for successful continuous delivery and continuous deployment methodologies, empowering those teams, so the DevOps teams, and sometimes ops teams for companies that haven't implemented DevOps as a whole to release software more frequently and reliably. And just a bit of, let's say, why have I split it and why am I only talking about continuous integration here? So some people, and a lot of people actually, talk about CI/CD as a whole, but that shouldn't be the case in most of the organizations. And nowadays, I can see a split and I can see a trend for companies to start to split their pipelines into CI and CD separately. This is because for rollbacks, for business purposes, and for business objectives, one might want to split the continuous integration, but don't actually deploy it or make deployment a manual step. One very simple example, if we have continuous integration mixed with continuous deployment in a single pipeline, what happens when we want to roll back our software to a previous version? Either you rebuild it entirely targeting a commit that is the previous commit version that contains the previous version, but that would be a waste of time because that means that you would have to run that commit once in an earlier stage and then again whenever you want to roll back. So by splitting continuous integration and continuous delivery, we could have a pipeline for continuous integration where for each commit only one build is being made. The resultant artifacts are then stored in wherever you want, and repository management like Artifactory, or even a simple S3 bucket. And then you can have a separate CD pipeline where you can target artifacts either manually or automatically to be retrieved from that storage, and you can deploy them. So this facilitates a lot the processes of rollbacks, or just selecting make it possible for you to select the targeted version manually as easily as possible. So this was just an apart. And what are the benefits of continuous integration? Well, there are a multitude of benefits that greatly enhance the software development process. So by automating the building and testing of code changes, we contribute to improved software quality by catching bugs and conflicts at a very early stage of development. This early stage detection reduces the risk of issues cropping up later on, when they tend to be a little bit more intricate and time consuming to fix. In addition to that, um, continuous integration saves valuable time and effort by streamlining the entire development workflow. What this means basically swiftly identifying and addressing problems, thereby minimizing the need for laborious manual testing and debugging. Consequently, this efficient approach can lead to shorter release cycles and a more seamless and productive development process overall, because you don't have manual steps of integration. It's all handled at the CI tool level. One of the key advantages of continuous integration is the ability, so like I said to you, to foster collaboration among team members, with code changes being consistently integrated into a shared repository. Developers remain well informed about the progress of their colleagues' work, and by fostering this communication and even coordination, we allow teams to work together more effectively and to address any conflicts or dependencies in a timely manner. Another crucial aspect of continuous integration is the establishment of a continuous feedback loop for developers. Through automated build and testing processes, developers receive immediate feedback on the impact of their code changes. This iterative feedback loop, again, empowers them to continuously iterate and improve their code, resulting in higher quality software overall. And how can we do it? We cannot do it without, or, I mean, we could do it without build automation, but that would be, you are handling manual steps on the integration side, but you still have manual steps on the build side. So how can we solve it? By leveraging build automation tools. So what is build automation? Build automation is basically a practice of automating the entire build, and we can even lead to the deployment process of software applications. It leverages recent tools like Gradle, Maven, Hand, Make, whatever. It depends on the project. And those tools automate tasks ranging from compiling source code to creating the artifacts and preparing the artifacts in a manner that they can be deployed. The primary aim of these automation tools the build automation tools is to simplify and again streamline the build process while minimizing errors that can occur during manual builds. By automating this process, developers can reclaim some valuable time and energy, which in turn allows them to focus on more crucial activities such as, actually coding and even creating rigorous application testing. Additionally, build automation tools facilitate faster feedback loops. By automating the build and even the deployment processes, developers receive immediate feedback on the success or failure of their code changes. And again, this rapid feedback empowers them to, identify it early, rectify it early, so that thereby they can minimize debugging time and enable faster iterations overall. Furthermore, it unlocks the potential for parallel and concurrent builds, which significantly enhances efficiency. Multiple build tasks can be executed simultaneously, harnessing the power and availability of our computing resources and reducing overall build time, which is a major problem. So I haven't seen a single organization where people wouldn't complain about big build times. And those build times could have been optimized by leveraging build tool automations, like caching systems, concurrent build steps, etc., etc. So this acceleration of development cycle enables quicker releases, and it overall boosts the productivity of all the teams that are engaged in the software development. Moreover, build automation tools can help to enhance collaboration among team members. With an automated build process, developers can easily share and replicate builds across a team. This in turn obviously fosters consistency and even enables smooth integration of code changes from multiple developers and creates a cohesive and efficient development environment. These are just some of the build tools um, benefits. And we can see that studies, I can even share you some links, but studies have shown, and they are easily accessible in the internet, have shown that implementing build tools automations efficiently can reduce build times by up to 90%. And even without too much knowledge on a build tool, just by trying to learn on the go and by reading the documentation extensively and by step improving the build automation process, people can get faster and faster and faster builds. And it's very visible, it's a very visible process. It even grants the DevOps team visibility and cost automation, which in turn it makes not only management aware of the valuable contributions that the DevOps teams have to a team or a project, but also on the FinOps side, so the financial ops sides, we can present results very easily and very quickly. And what tool should we master for this? Well, it really depends on the projects that you are working on. If you are working, for example, on Java projects, you can use Gradle, Maven, or Hand. But on the other hand, if you are using, I don't know, C++, those tools are not ideal. Depending if you are within the .NET framework or not, you can even use MS Build. You can also use simple make files. You can even use the G++ compilation. So the GCC, sorry, compilator. So it really depends on the project that you are in or the tools that you are using, the technologies that you are using. But for this concrete example, I will expand a little bit more with Gradle. So what is Gradle? Like I said to you, Gradle is a build automation tool that is used to manage dependencies and build Java projects. It uses a Groovy-based DSL, so it's the configurations of Gradle are built with Groovy. However, nowadays it also supports Kotlin, so you can, define the build logic not only using Groovy, but also using Kotlin. And by having this build logic as code makes it very easy to read, very easy to write, very easy to iterate on. And Gradle is designed to be flexible, which in turn allows developers to customize their builds according to their specific needs. It can handle complex builds with multiple modules and dependencies, and it also supports a wide range of plugins that can be used to extend its functionality. Setting up a Java project using Gradle, it can be a bit daunting at first, but it's actually pretty straightforward. There's even some IDEs that already give you, let's say, a starting project with a very basic Gradle solution already configured. So, for example, IntelliJ does that for you. When you are creating a project from scratch, you can define it as a Gradle Java project, and it will take care of setting up Gradle for you. If you are doing it manually, however, the first step would be to create a new directory for your project and then navigate to it using any kind of terminal. Once you will be there, you could just, assuming that you have Gradle installed on your machine, you could just run the command Gradle init to initialize a new Gradle project. That would create the basic structure of the project, including Gradle, build.gradle file, which is where you will define your project dependencies and other settings. And next, you would have to add any necessary dependencies to your build.gradle file. And this could be done by just adding lines like implementation group, name group with the version to the dependencies section of the file, but more on that later. And just another tip, Gradle will also automatically download and manage the dependencies that you have defined for your project for you, which again, it's a very nice way to automate these build steps for any kind of project. So another thing that I want to talk about to you is what is a Gradle wrapper? And a Gradle wrapper, if you already knew Gradle, you'll probably have heard about this. So this is basically a script that allows a project to use a specific version of Gradle without having to install it manually on every machine. So if you are, I don't know, entering a new team, you are being onboarded on that project and they use Gradle, instead of you having to download Gradle with that specific version on your machine, most of the times what people have is they have a Gradle wrapper submitted alongside their code in the version control, the VCS um, of the project, so in their repository. And you can just download that Gradle wrapper and you will essentially have a self-contained version of Gradle that is distributed alongside the project source code, and it can be used to run that project. The benefit of using this is that you ensure that everyone working on the project is using the same version of Gradle, which can prevent compatibility issues and make the build processes more consistent across developers. And additionally, it simplifies the setup processes for new developers who join the project, join the teams, and they already have a ton of information to be dealing with, and they don't need to worry about at least installing Gradle themselves. And so, like I told you, some of the benefits of using a Gradle wrapper in the Java project would be simplifying the build process by ensuring that everyone works on the project by using the same version of Gradle, eliminating the need to manually install and configure Gradle on your local machine, which can be time-consuming, and every step that is manual is prone to error. So by eliminating manual steps, you eliminate problems that would be generated by human handling. And finally, another benefit is that it just makes it simple and easy to share the project with other developers. So since the wrapper includes all the necessary files and their dependencies, anyone can clone the repository and start building on a project without having to install any of the dependencies. So what are the key takeaways of all of this? In conclusion, we have discussed about the importance of CI and build automation in modern software development. Continuous integration allows developers to integrate code changes frequently and automatically, which in turn ensures that the application is always stable and ready for release. And on the other hand, build automation tools simplify the build processes and reduce errors, enabling teams to focus on delivering new features and functionality. We have also learned that Gradle is a Java build automation tool that simplifies the process of managing dependencies and building Java projects. By using Gradle, we can save time and effort while ensuring that our project is being built correctly and consistently every single time. Additionally, we have seen that by using a Gradle wrapper, we can further simplify the build processes by allowing us to specify a specific version of Gradle to use within our project. This ensures that everyone is working on the project is using the same version of Gradle, and this can help, of course, to avoid compatibility issues and make it easier to collaborate on the project. So, project time. I will share this to you in our Discord server, but basically what I would like you to do would be to set up CI pipeline using Jenkins, which is very easy to install, and the installation site has a very good step-by-step um, onboarding. And once you have configured and installed Jenkins on your local machine, I would like you to create just a simple repository. It doesn't have to contain too much stuff in it. And then I would like you to create a Java project in Gradle and integrate it within Jenkins. So I would like you to build it within Jenkins, run one or two tests within Jenkins by using the Gradle tasks, and finally, as a bonus, to generate reports on that build and on those tests and store it within Jenkins. So if you can do this, you will basically know how to work with Gradle and Jenkins, and it will be, very easy. I have put here a mental note for myself to insert a link of a GitHub repository here because I will create this later today. I will create a very simple Java project with one or two automated tests already done so that you can simply copy my GitHub project, create a repository, or even fork it, create a repository of your own, clone the project, and then take it from there on integrating that project with Jenkins and fooling around with Gradle to test out the tool. Again, don't hesitate to reach out if you have any kind of question, need assistance to do any of the steps. And what I can basically say is good luck and happy coding.